Hey guys, welcome back. Today is day 49. Let's start with a warm-up. You should have printed it out and tried it. I'm going to go over the questions right now. So last class we learned how to do systems of inequalities. So we have two inequalities here. We're going to start by graphing them both. So I start at my y-intercept of 1 and my slope here is 1. I'm doing the first equation. Notice it is less than, so it's just going to be a dashed line. Okay, so when I shade, it is less than, so I'm going to look at my y-intercept and go less than the line, and I'm going to shade this region. Okay, you could also test the point out 0, 0. 0 is less than 1. The second equation, when we look at it, it is y is greater than negative 2x plus 4, so we start at our y-intercept of 4. Okay, and our slope, and our slope 1, 2, 3, 4, our slope is going to be a negative 2, so we're going to go down 2 and over 1. Okay, and again, this one is also a dashed line. Okay, since it's greater than, when I do go to shade, it's actually going to be to the above the y-intercept. So here's my y-intercept. I'm going to be above that line. Okay, so then you notice that the solution is right in this double shaded area. Okay, if it can be any of the ordered pairs in the double area, if it lands on a dashed line, it's not part of the solution set, but if it is on a solid line, it would be. Okay, so now let's look at number 2. Number 2, we've got to put it into slope-intercept form. So the first one, we're going to bring, let's do 2y is less than or equal to negative x plus 4. Then I'm going to divide both sides by 2. So y is less than or equal to negative 1/2 x plus 2. All right, so I'm going to graph that line. I go down one and over to the right, so it's going to look like this. Okay, it's going to be a solid line. Okay, and because it's going to be less than, it's going to be, I look at my y-intercept and I go less than, so it's less than that value, so I'm going to shade below the line here. All right, now when I look at the second line, it's we're going to think of Vox, and it's a vertical line at x is negative 2. So I'm going to go to negative 2. All right, and this is going to be a solid line. All right, and it's going to be greater than. So when I highlight, it's going to be on the number line. Think of the x values greater than negative 2, which would be to the right. Let's do that here in a little this color. All right, so our double shaded region would be right in through here. There's our solution. All right, number 3, we've got 2 horizontal lines. The first one is at 3, 1, 2, 3, and it's going to be a dashed line. And y is going to be greater than 3, so when we shade it, it's above the line here. Okay, now the second line is y is less than negative 2, so we're going to draw, and that one is going to be a dashed line as well. So we go to negative 2 and we make a dashed line. And since it's less than it, okay, it's going to be below the line y-axis here. So if you notice with this example, there's actually no solution because we don't have an overlapping area. Okay, so when number 4 says which graphs have no solutions in quadrant 4, before we get into let me just do a quick review of quadrants. So when you have the coordinate grid, quadrants are 1, 2, 3, and 4. And usually quadrants are in Roman numerals, and to make it, I like to think of the letter C. It tells you what order, 1, 2, 3, and 4. That might help you. Okay, so quadrant 4 is where your x is positive and your y is negative. So no solutions in quadrant 4 would be, looks like 1 has solutions in quadrant 4, so does 2, so the answer here would be 3. Okay, which graphs 1 through 3 have negative 2, 1 as part of their solutions? So we look at the ordered pair negative 2, 1 here, and look, it's not even in a shaded area. Okay, number 2, if we say negative 2, 1, we're right on the solid line there, and since solid line includes the solution, is part of the solution set, we can say that graph number 2, because 3 has no solution, so can't be number 3. And number 6 says, is the point 1, 4 a solution to graph 3? Well, graph 3 has no solution, so we're going to say no. And which graphs in 1 through 3 have solutions in quadrant 1? So remember, quadrant 1 would be where it's positive, positive. So if we look at number 2, we do have a little bit of an area right in through here. So it would be 2. And then we do have here, there's quadrant 1. So it's going to be 2 and 1 or 1 and 2. Okay. All right, so moving on, looking at the next question. Now we're going backwards. Now it says to write a system of linear inequalities represented by the graph. Okay, so when we look at that, we're going to identify, first I'm going to start with this line number 1. My y-intercept is going to be at 2, and my slope is going to be, so there's my y-intercept, my slope is going to be rise 1, run 2. So I've got a positive 1/2. All right, so since this is the double shaded area, for line 1, we're actually shading below the line like that, okay, in order to get that double shaded area. So if I look at my y-intercept, you can see that I've shaded lower than or less than, okay? So my system, my equation would be y is less than, and it's going to be equal to, because it is a solid line, 1/2 x plus 2, okay? Now the second line we'll do, okay, let's look at number 2. Let's look at this one right here. And number 2, the equation, it starts at a y-intercept of -1, 2, 3, looks like -4, okay? So we got -4 for that one. Is it -4? 1, 2, it's actually -3. So our b is -3, and then our slope is going to be, we go up 2 and over 1, so its slope is going to be a -2, okay? So in order for that to be the shaded area, we had to shade this way, okay? So if we look at this, the y-intercept, we've actually shaded less than or lower than that line. So it's dashed, so y is going to be less than -2x minus 3. So these two make up the system. All right, moving on to our notes today. So homework is out there. The key is there if you want to look at yours from last class. All right, we're going to start with a quick review. All right, so again, these are just like the warm-up. Instead of the first one, we've got a vertical line, x is greater than 2, so we go to 2. All right, we make a dashed line, and it's greater than, so it's going to be to the right here. The second is y, it's going to be a horizontal line. So y is less than or equal to -3. So when we make a horizontal line, this one's going to be solid. Okay, and when we shade it, all right, it's going to be down below here. Let's do it in a different color, kind of an orangey. All right, so you can see in this area here, this is actually the solution set right in through here. Okay. All right, so we're the double shaded region. It's hard to see on this, but with pencils, you should be able to tell. All right, if I look at number 2, I've got y is going to be less than -x minus 2. So I'm going to start by graphing that one, and that's going to be so it's going to be a -1 slope. Okay, it's off a little bit. So we're going to make a dashed line. All right, and since it's less than, when we go to shade, it's going to be down here. All right, now the second line, when we put it in slope-intercept form, -y is going to be less than or equal to -5x minus 3. And then we divide both sides by -1. So y is actually greater than or equal to 5x plus 3. All right, so I'm going to start at my y-intercept of 3. My slope is 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, and over 1. Okay, and then that's going to be a solid line. Okay, and so it's greater than, so I look at my y-intercept here, all right, and that means my y values here need to be shaded. All right, so let's shade them, do a little pink here, okay? So you can see the overlapping shaded area is going to be right in the solution set here, so we're going to put the solution here. Okay, all right, so that was just a quick review from last class. We also learned how to see if a point satisfies the system. You could either graph both of these and see if that point is in the region, or you can plug it into the two inequalities. 5 times our x is 2, plus a -y or minus 2, is that greater than or equal to 3? So 10 minus 7 greater than or 3, or 10 minus 2, sorry. 10 minus 2, and 10 minus 2 is 8. 8 is greater than or equal to 3. So that's true. So we're going to go ahead and do the second one. Y is greater than -2. So when we plug it in, our -2 is greater than -2. That's a false. Now remember, they both have to be true for it to be satisfied. So this does not satisfy. That's a no. Okay. All right, moving on to the next one. All right, now we're going backwards. All right, just kind of like in the warm-up, we identify the slope and the equations of the line, and we come up with the inequalities. So if you look at, I'm going to label this as my first screen, my first equation. My y-intercept I like to identify first is 1. My slope in this one is going to be a -1 because I can go down 1 to the right, so that's going to be a -1. All right, it's going to be it's a solid line, and I need to know, so it's shaded. In order to make this the shaded region, I'm shading below the line like this. Okay, so my y-intercept, you can see it's the values less than it. So this is going to be y is less than or equal to -x plus 1. Okay, so there's one of the inequalities. Now the second one is a horizontal line. So because it's horizontal, I think of hoy, so I know it is a y. And if I look at it, my y is at 3, but in order for this to be the shaded region, it's going to be this direction. Okay, so y is actually going to be less than 3. So there's my system right there. Okay, you guys can pause the video and try number 5, but I will go ahead and identify the slope and the y-intercept. So this one was line 2. All right, so line 1, okay, my y-intercept is going to be 2. My slope is going to be -1. All right, and since I'm shading above the line, it's going to be greater than or equal to. So y is going to be greater than or equal to -x plus 2. All right, and now the second one, all right, if I look at the second line, okay, this is going to be here. My y-intercept is at -1, okay, so b is going to be -1, and our slope is going to be at 1, 2, 3, 4 over 1, so our slope is going to be a -4. All right, in order for that to be the shaded region, we're shading this direction, so our y values are greater than, so this is going to be y is greater than or equal to a -4x minus 1. Put it together. Okay. All right, so let's go ahead and let's have you guys try 6 and 7 on your own. Okay, pause the video, give it a try. I'm just going to put the answers up for 6 and 7. All right, so number 6. So pause it when you're ready, see if you got it. Y is greater than or equal to 1/3 x minus 1, and y is less than or equal to 4/3 x plus 2. Okay, that should be the system. All right, number 7, you should have y is less than -2x minus 3, and y is greater than or equal to 2x plus 1. All right, hopefully you got those. If you didn't, go back to the key that's posted on Schoology and see if you can detect your mistake. It's pretty detailed. All right, number 8. Determine which region. So the regions are not going to necessarily be the quadrants. Okay, in this case, they're looking at it does happen to line up, but sometimes it's not. So you've got to basically get the two equations. All right. So the first equation, if you put it into slope-intercept form, it's going to be y is greater than or equal to 5/2 x plus 2. All right. Don't forget you had to divide by a negative, so you had to flip that sign. So that's that line right here. Okay. So for shading, it's greater than. So I look at my y-intercept. So I'm shading this direction with that line. Okay, now the second line here, when we put it into slope-intercept form, it's going to be y is, so the second one we have would be 2y is greater than or equal to x minus 4, and then we divide by 2. All right, so y is greater than or equal to 1/2 x minus 2. Okay, so the second line is going to be greater than or equal to, so you're going to go above, and I'll do that in red so you can see. So when we go above, we can see our double shaded area is right here in region number 2. Okay, so that would be region 2. All right, so now I just want to just review some word problems. We're not going to solve the word problems, but we are going to set them up. And we're going to set them up the same way that we set up system of equations. So always start out with your let statement, and then you're going to have two inequalities, okay? So Bob has at least 5,000 in savings. His savings balance is 3 times. So he has at least 5,000. His savings balance is more than 3 times greater than his checking balance. So for this one, our let statement, let's let X be the savings and let Y be the checking. Okay, so the first says he has at least $5,000 in savings. So that means that X is going to be greater than or equal to 5,000. Okay, because at least means it could be 5,000, but it could also be greater. The second inequality, his savings balance is 3 times greater than his checking balance. So it's going to be greater than 3Y. All right, so there's our two inequalities right there. All right. Number 15, Jonah is going to the store to buy candles. Small candles cost $3.50 and large candles cost $5. He needs to buy at least 20 candles. He can spend no more than $80. So we have small candles and we have large candles. So that's going to be our let statement. We don't know how many of each we have. All right, so we'll start off and just say, let's let X be the small candles. All right, and let's let Y be the large candles. So we're just interested in the two inequalities. All right, so if we have, we need to buy at least 20 candles. That means if we take our small candles, we add our large candles, we're going to have greater than or equal to 20. Okay, that's going to get us, okay, up to 20, greater than or equal to 20. But he doesn't want to spend more than $80. Okay, he can spend $80, but no more. So small candles are $3.50, so 3.5x plus 5y, okay, and it has to be less than or equal to 80. There's our two inequalities. All right, the next one, John is doing a fundraiser for school. He needs to sell at least $200 worth of items. Shirts cost $10 each and hats cost $8 each. He must sell more than 12 hats. So we don't know how many shirts we have. Let's let X be shirts. All right, and let's let Y be hats. So our two inequalities, he must sell more than 12 hats and he needs to sell at least $200 worth of items. So let's do the money first. So shirts are $10 each, so 10x, and hats are $8 each. And he needs to sell at least $200 worth of items, so that's greater than or equal to 200. And since he must sell more than 12 hats, Y has to be greater than 12. So there's our inequalities. All right, now we're going to interpret a graph. All right, so if we look at this graph, it says Magwani wants to download songs and lectures on his smartphone. He plans to download at least 30 songs and lectures, but can download at most 300 megabytes of data, condition B. The graph represents the constraints. So here we have on the x-axis the number of songs, and then he has the number of lectures. Notice we're only modeling this in quadrant 1, and you're going to see that a lot because that's where we get our positives, all right? So remember our quadrants. So many times with word problems, you're just going to get it modeled in quadrant 1. All right, so this is 0. So right here, this is kind of like the 0, 0, all right? And so your songs are on the x-axis, your lectures are on the y. When we graph the two inequalities, we find that this area, the overlapping area, is the solution area. Okay, and since the question is asking for what is the greatest number of lectures, so the greatest number of lectures would be way up here because our lectures, and we go over, and it looks like it would be at 15. So 15 lectures. Okay, all right, and then finally, looking at this graph, what is the solution? Notice nothing overlaps. Because nothing overlaps, it's no solution. This one should start to get pretty easy. All right, so I recommend that you get the homework done today, 49B, and check it with the answer key that's in Schoology. Bye.